All right, here's a 4.2, part 2, rates of change in velocity. We're just going to go over two quick problems and then be on your way. So this one right here, we want to find the average rate of change of the function of a given interval. Here's the function right here, and then here's the interval given, 1, 2. So we need to find the average rate of change over that interval. So it's pretty much how your book writes is this. And what does that mean? As you know, this symbol means change, as hopefully you've seen in your math class before. So it's a change of distance over a change in time. This is considered your time, and whatever your outputs are, whenever you use these inputs, will be the distance, okay? So your denominator is simply going to be 2 minus 1. Right, because that's a change in time. We went from 1 to 2. And then position, when we put 1 in and we put 2 in, we're going to subtract those values. We put 2 in, you're going to get negative 1/2. We put 1 in, you get negative 1. Okay, when you subtract them, you're going to get 1/2 on the numerator and 1 on the denominator. So your average rate of change for this problem would be 1/2. Now, part 2 of the directions say, compare this with the instantaneous rate of change at the endpoint. So what does that mean? The instantaneous rate of change, so these are your inputs here, 1 and 2. We're dealing with that. We want to find instantaneous rate of change. We're finding the derivative and then plugging those values in. So for the derivative of f of x would be equal to, since it's just like saying negative x and negative first, we need to subtract 1, then multiply the front by negative 1, because that was what your original exponent was. So negative 1 times negative 1 is 1, and then when we subtract the exponents, you get x to the negative second is your derivative. Another way to write that is 1/x squared. And then for the endpoints, the instantaneous rate of change at x equal to 1, it will be equal to 1 squared is 1, so 1 divided by 1 is 1. At 2 squared is 4, and then we have 1/4. So your instantaneous rate of change at x equal to 2 is 1/4. All right, so let's say we have this position function for free-falling objects, and I'm giving you information such as we have an initial velocity of, let's say, 120 meters per second. What is the velocity after 5 seconds? Okay, so a couple things. In order to find the velocity at a certain time, we're going to need to find the derivative, okay? And so the derivative of s prime team is also known as the velocity function. So we're going to have negative 9.8 t plus b sub 0. b sub 0, what does that represent? That represents our initial velocity, okay? Or velocity at time 0. So that's where the 120 comes into play. Okay? And then you want to know what the velocity is after 5 seconds. So we're going to put in 9 in for t, for 5, not 9, and solve. As a result, you will get 71, okay? So that would be the velocity after 5 seconds. So it will be 71 meters per second. Part 2 asked what will it be after 10 seconds. So once again, just put in 10 in for t. And your velocity will be 22 meters per second. All right, and that's it. Appreciate you watching, and we'll see you in class. Bye-bye now.